All right, so part 4, we're going to look at systems where you have to multiply both equations. And you guys already figured this out a little bit, as you brilliantly demonstrated already. I just want to formally go over what this means, or how we would solve these. So let's take something like this. 5x plus 4y equals negative 14, and 3x plus 6y equals 6. All right, there's nothing here that I can multiply this equation by to make either x or y into these coefficients, unless it were a fraction. And there's nothing that I could multiply this equation by to make x or y into these coefficients, again, unless it were a fraction. And you can actually solve these by multiplying with a fraction, but that seems to be the least popular way of solving them. Typically what we're going to do, there's no, 3 times something doesn't equal 5, right? But if I multiply this whole equation times 5, and this whole equation times 3, and let's make this one negative, then I'll end up with a negative 15x and a positive 15x. Okay? So, if I just rewrite both equations, I have negative 15x minus 12y equals 3 times 14, 30 plus 12, 42. And then I've got 5 times 3x, which is 15. 5 times 6, which is 30. And 5 times 6 again, which is 30. These are now ready to add, because I have negative 15 and 15. And I'm going to go through this part pretty quickly because you guys know how to do this already. Negative 12 and 30 is 18. 42 and 30 is 72. Oops. Divide both sides by 18. Y equals, so I'm trying to think of something times 18 that equals 72, right? The first thing that I'm thinking of is what numbers times 8 give me a 2 in the ones place?
That's what I always do.
Right? So I know 8 times 3 is 24. 8 times 4 is 32. And so then by doing that, I usually can find the answer if it actually works, right? And 18 times 4 is 72. So my y is 4. Okay, plug that in. 5x plus 16 equals negative 14 because 4 times 4 is 16. Subtract 16 from both sides. 5x equals negative 30. So x equals negative 6. And my answer is negative 6. If I wanted to solve for x first, what would I multiply these by? If I wanted to get rid of the y's, what would I multiply the first equation by?
You multiply the 3x plus 6.
You'd multiply the first one by negative 6 and the
Negative
second
6
one by 4.
and 4. Actually, I could do that, or you see that it would also work if I multiplied this one times negative 3 and this one by 2, because I would end up with 12. So that would also work. All right, questions on this? Just multiplying both equations to set it up. All right, now I want to look at something a little different, which again, we already kind of discovered this, but I want to go over it for me. So let's say I had something like this. 2x plus 6y equals 10. 3x plus 9y equals 15. Okay, I don't see anything. There's nothing set up to add together here. Right? I don't see anything. I can't multiply 3 times anything to get 2 unless it were a fraction. I can't multiply 9 times anything to get 6. So I'm going to have to multiply both equations, right?
Wouldn't it be easier if you do first one by negative 3 and then
Okay.
second one by 2?
Let's multiply this one times negative 3 and this one times 2. So I'm just looking at the coefficient, right, and copying it down, basically. So here I have negative 6x minus 18y equals negative 30. What do I have in the second equation?
6x plus 8ty equals 30. So it's so it's infinite solution.
Yeah. There's a couple things we can do here. One of them is, if I add these together, I get 0 equals 0, which is true, which suggests that I have infinite solutions. Okay, infinite solutions. But what does that mean? I'm looking for the point where two lines meet on a graph, right? That's what solving a system, a 2 by 2 system is. How can there be infinite points where those lines meet? Yeah.
It means that like it doesn't have to be a certain, they're like equal equations, so the ratio could be.
Okay. So the equations, look, if I multiplied this one times negative 1, it would be negative 1 times all of this would be 6x plus 18y equals 30. So really the reason they cancel out is because they're the same equation, right? This and this are actually the same equation. Yeah.
So it's like that, it's just two lines in the exact same place?
Right. What I really have, right?
It's 2 lines on the same line.
Yeah, what I really have here is 2 lines that are really the same line. I just have 2 equations for the same line. So there's infinite solutions because those lines meet everywhere. They're the same. Right? Can anyone think of a case when I would have no solution?
If the lines don't meet.
Yeah, what do we call 2 lines that don't meet?
Parallel.
What is it, Sachi? They're parallel, right? So the only way we can get no solution, right? I mean, I could draw 2 lines that look like they'll never meet, like this line and and this line. They look like it would take forever for them to meet, right?
They meet up there.
But yeah, eventually they would meet,
So they have to be perfectly parallel if they don't meet.
right? If I were to like extend this perfect line, right? And this probably won't even be on the video, but right, if I keep going, eventually they met. So for them to really be no solution and never meet, they have to be perfectly parallel. Doesn't matter which direction.
Which is impossible to draw.
Perfectly parallel, which would be very difficult for me to draw. Because
Wasn't it technically impossible? Because you have to draw 2 perfectly straight lines exactly.
yeah, it'd be hard to draw that like exactly that. If you used a ruler, you could do it pretty well. All right. What do we know about parallel lines? What do we know about them?
They never meet.
They never meet, so there's no solution.
They're parallel.
What else did we learn about parallel lines, though?
What is it? Something about the equations.
Way back in like
Be like the same
December.
with a different point.
Okay, the equations are the same
Slope would have
in
to be the same.
the slope,
Oh,
right? Parallel lines have the same slope, but they have different intercepts or different whatever, right? So if we have parallel lines that never meet, we have no solution. If we have the same line, but wouldn't the same line also have the same slope? Yeah, it's the same line. Then it would have infinite solutions. So I still think the way to do this is to do what Gary taught you, right? If 0 equals 0, if it's true, you're good. That's infinite solutions. That's the same line. But if we added them together and we got 0 equals 10, there's no way for 0 to ever equal 10, so we have no solution. Okay? So you just go as far as adding them together. X and Y will both drop out, and you'll have something equal something. And you'll be able to tell, okay, are they parallel or is it the same line but no solutions or infinite solutions. Questions? Let's see, everyone's here today, so I'm gonna stop the recording right there.